Hello guys and welcome back to the third video of our full stack React development series, and in this video over here we will be learning how to implement the backend of our system. So in our previous video you have seen that how beautifully and incrementally we have cloned each and every component of our Facebook UI, starting from the sign up page till the home page of our Facebook application. And over here in this tutorial we will be learning how to create the backend support for all the components that we have developed in our front-end application. Because without a proper backend support, it is meaningless to create an application only on the front end. So let's start with building the backend of our Facebook cloning application. So as you know, over here we will be implementing the backend REST API using the Spring Boot application. And over here as our database, we will be using the Firebase for storing all the images, and we will be using the NoSQL database, that is the Cassandra application, for storing all the metadata of the user. So without wasting much time, let's start with the development of the backend support of our Facebook application. But before going into the implementation of our backend support, let's first discuss the architecture by which we will be creating these backend APIs. So over here, let's first discuss some basic system design that you need to know before implementing the backend support using the Spring Boot application. Because at the end of this video, it will be very easy for you to implement any of the API that you want to design for your application. But if you really do not know the basic structure or the basic system design of a particular application, it will be very difficult for you to enhance that application. And this system designing is the core concept for designing or implementing any application for your business. So let's start with understanding the basic system design that we will be following during this course over here. So the architecture that we will be following over here is quite simple and basic, and it does not have all the components that we actually have in our actual Facebook application, because over there the amount of application and the amount of services that is working behind that Facebook application is quite huge and tremendous. So over here, to make it short and simple, over here I will be explaining a basic system design architecture that will be helpful for you to understand the framework. So let's see how we will be implementing the backend services over here. So on the left side of this design, you can see we have some clients over here in which the actual Facebook is running. And over here you can see we have provided two servers. One is the web server where our front-end UI is hosted, and one is our backend server where our API services are running. So since this is a microservice architecture, that is why we are deploying the two components separately in two different machines. So let's first understand that how and what will happen on the backend of our application. So whenever a user comes to our application, that is the Facebook cloning app, and hits the Facebook cloning URL, at that time the request first goes into our web server, and over there as soon as the request comes to the web server, the user can see the login page of our Facebook application. And within the login page, the user have the provision to give the correct credential to log in to our application. And as soon as the user puts the correct credential, that is the username and password, into their login screen and clicks on submit, the request goes to our backend application, and that is it hits the Firebase authentication system. And over there the Firebase application system first validates that whether the user is an authenticated user or not. And if the user have given a correct credential, it will send the metadata of the user in the response of this API call. And once we receive the metadata of the user, we can surely tell that the user have put a correct credential for the login purpose. And once the user have put the correct credential for the login purpose, we move the user in the forward direction. And what we do, we try to save the metadata of the user using the services that we have implemented for our backend support. And thus we use our first service that we have created on our API service, and that is the user service. And with the help of the user service API, we save the metadata of the user into our local database, that is within the Cassandra service. Which means that whatever the credentials and the metadata what we got from the Firebase application are right now saved into our local database, so that in the future whenever the user is signing to our application, we can retrieve the corresponding metadata from our local database for future use. And once the metadata got successfully submitted into our local DB, we sends a acknowledge in response to our user service API call. And as soon as the web server get a positive acknowledge from our user service API, it will move forward the user to the next page, and that is the home page, which is actually the main dashboard or the main home page of our Facebook application. And once the user lands to the home page of our Facebook application, it is quite obvious that we have to show all the relevant content to the user, such as the post, the comments, and all the relevant information that we need to show on his home page. And for that, we will be sending another request to our database to retrieve all the information about the post and the comments for the home page. And for that, we will be using the other REST API, that is the post service, the status service, and the comment service. And once all the services works together, we can show a complete full-fledged working dashboard to the Facebook user. So this is the complete architecture or the way the data will flow across the application. So this will be much more clearer to you when we will be going in detail of each and every service that we will be implementing over here. So let's go into detail on each and every services that we will be implementing over here. So the minimum amount of service that we need to create to build our Facebook cloning application are: number one, the post service, which will be responsible for handling all the CRUD functionality for the user. For example, if the user submit a post, then the post need to be submitted into the database. As well as once the post gets submitted to the database, it should come up and show into their home page, and for that we will be using the fetch API over here. So all type of CRUD functionality will be handled by the post service that we will be implementing over here. The next comes the user service, which will be responsible for retrieving the data about the user. So for example, whenever the user is logging or signing to our application, those data will get persisted into the database using the user service. And whenever the user is coming back to our application by using the sign-in operation, at that time all the metadata of the user will be fetched from the database by using the user service that we will be implementing over here. Next comes the status service, which will be responsible for handling all the status of the user. For example, at a particular instance of time, a user is uploading a status into the Facebook application. And as soon as the user uploads a status into the Facebook application, the save API of the status service will get called. And using this service, we will be persisting that information into our database. And the last and the final one is the comment service, which will be responsible for handling all the comment for particular post submitted by the user. So these are the minimum number of services that we need for cloning our Facebook app. So there can be 100 more services that you need if you want to build a complete running Facebook app over here. For example, for enhancement purpose, you can create a like service which will be responsible for capturing all the likes and react posted by the user, or there can be one more service that will be responsible for handling all the share functionality of the post. So in this way, for each and every functionality, you can have n number of microservices that will be responsible for handling that corresponding functionality. But over here, since we are building a prototype of Facebook, that is why these are the 4 services that we will be majorly implementing over here. Now let's go into the deeper detail that what are the database schema or what are the table structure where we will be saving the data. So the first table that we will be using is the user table, where we will be saving some of the metadata of the user, such as the user ID, which will be a unique identifier for a particular user, the username, the image URL for the user, the activity status, and the joining date. So these are the minimum number of metadata that you need to save for a particular user. And with the help of this metadata, we can successfully build the prototype of our Facebook application. Next comes the status table, which will have the status ID as the unique identifier for each and every status, the user ID who is uploading the status, the image URL of the status, and the date and time at which the status got uploaded. And the next table and the most important table is the Facebook post, which will contain the information of all the posts that we are saving for our Facebook application. And the first one is the post ID, which is again a unique identifier for each post submitted by each user over here. And over here, while saving the user post, we are also saving few of the metadata of the user, such as the user ID and the username. Along with that, we are saving the description for the post image URL, and the like count over here. And also we will be saving the date and timestamp at which the post got submitted or uploaded into our database. And the next and the final table that we need for our Facebook application is the comments table, where we will be saving all the comments for a particular post. So I hope you guys are clear with the database schema by which we will be saving the data into our Cassandra database. Now let's go into the detail about all the services or the REST API endpoints that we need to create over here. So first one is the user service. And for the user service, as per our REST protocol, we will be primarily creating three endpoints. One is the post endpoint for submitting the data, one is the get endpoint for retrieving the data, and one is the delete for deleting a particular user from our database. So over here you can have one more endpoint, and that is put for updating the metadata of a particular user. But over here, since we are doing a prototype of our service, and that is why we will be implementing these 4 API endpoints over here. Now the next service that we will be using is the status service over here, and similarly over here we will be having three endpoints. One is the post for saving the data into database, get for retrieving the status information from our database, and delete for deleting a particular status from our database. So over here you can see I have given a star mark over here because I won't be implementing this functionality over here. Rather, I will be keeping this as an enhancement problem for you guys so that you can implement this at home so that you can learn something from my tutorial. Next comes the post service, which will also have three endpoints. Number one is the post, number two is the get, and the last one is the delete. And the last and the final API service that we will be creating is the comment service, where we will be saving the comments by using the post API. We will be retrieving the particular comment by using the get API, and the delete API we will be using for deleting a particular comment. So these are the main 4 services that we need to build for creating our backend support for our Facebook application. And since over here we will be implementing the backend support using the Spring Boot framework, and that is why each and every REST API should follow this protocol. Means all the REST API should have a controller class which will be responsible for handling all the REST API requests. Number 2 is the service class which will have all the business logic for a particular service, and number 3 is the repository class which will be responsible for saving the data into our database. So hopefully this complete architecture have given you some sense of how we are planning to create the backend services for our Facebook cloning app. Now let's go into the detailed dive on coding and implementing each and every services that we have discussed over here, so that it will be much more meaningful and helpful for you guys to understand the complete flow. So without wasting much time, let's start with the video on the implementation of our backend service using the Spring Boot framework. So let's start with building our backend service for our Facebook app. So to create an empty Spring Boot project, we first have to go to the site called as Spring IO Initializer. So over here we will click on the first link, that is the Start Spring IO. So over here, for creating the REST API for our Facebook app, we will be going with the Maven project. So over here we will select the Maven project and we will keep the language as Java. So let's change the metadata over here. So I will keep the group name as it is, and let's change the artifact name as Facebook API. And over here, let's select Java 8 as our Java version. Now within this Maven project, let's add the dependencies that we need for creating this backend system. So the first dependency that we will be selecting is a theme live by Spring. Next, we will be selecting the Spring JPA. After that, we will be selecting the REST repository. And the last and the final dependency that we will be selecting is the NoSQL database, and over here we will be using the Apache Cassandra. So over here we are done with all the dependencies that we are needed for building this project. So let's click on generate. So over here you can see our project is getting downloaded. So let's open this project, and over here we will unzip this project. So here you can see we got the entire project called as Facebook API, which is our starter project for building our REST API. So let's now open your favorite code editor. I'm using Eclipse over here. And over here, let's create a workspace called as Facebook API. So now over here, we first have to import the Maven project that we just have downloaded from the internet. So we will click on import, and over here under Maven we will be selecting the existing Maven project, and over here we need to browse to the folder that we have downloaded right now. So let's select the folder over here, and over here you can see the POM file that is associated with this project got included over here. So let's click on finish, and here you can see we have successfully imported the application into our Eclipse. So let's build this app. So over here you can see our project is installing all the necessary dependencies that we need over here. So this will take a couple of minutes or so. So let's over here wait for a couple of minutes. So here you can see all the dependencies got installed that we need for this project. So let's start with building this app over here, and for that we will go to the first Java file where our main class exists, and that is the Facebook API application. So over here you can see we have the main class residing over here, and this is the starting point of our Facebook REST API service. So let's over here start with building the REST API that we need for creating the front-end application. And as we have discussed over here in our documentation, the first service that we will be creating over here is the post service. So over here the first endpoint will be the post, second will be get, and last one will be the delete. So as we have discussed, the post service will be responsible for submitting the data from the front end to our NoSQL database that we are using over here, that is Cassandra. The second one is the get, which will be responsible for retrieving all the posts from our database. And the last and not the least is the delete, which will be used for deleting a particular post from the Facebook. So let's start with building this post service for our Facebook cloning app. So as you know, for creating a REST API using the Spring Boot framework, we normally create 4 modules. Number 1 is the entity class, which have the definition of the post. Number 2, the controller, which will control the flow of the execution. Number 3 is the service class, which will actually deal with the business logic of our API, and the fourth will be the repository service, which will be responsible for submitting the data into the database. So let's start with building the first component or the first module of our REST API, and that is the entity class, and I will put it within our entity package. So let's first create our entity package over here. And within this entity package, I will be creating the first entity class, and that is the post class. So over here, since this is our entity class and we will be using the Cassandra as our NoSQL database, we will be marking this with the annotation called as table. And let's use the Cassandra library from here. So always do remember, while you are annotating with the table, use this Cassandra library, not the one provided by the Java persistent. So let's import this library over here. So as we have discussed in our previous tutorial, that for a particular post, we at least need this component for rendering a post into the UI. And the necessary component is the post ID, which will uniquely identify a single post. Number 2, the user ID, the user image, and the username, which will define the user who have created the post. Number 3, the description, that is the actual textual content for a post. Number 3 is the post image, which will be the URL for the Firebase application. And the last one is the total number of likes we have received for this post. So let's create this attribute into our backend service so that we can also generate an API service that will give us this corresponding result. So let's start with creating this attribute over here. So the first one will be the unique identifier for a particular post. So over here I will create a private variable, and over here this post ID will be the type UID, which is actually universal unique identifier, which is provided by the Java util library. So since this will be the primary key for our post service, I will annotate this attribute with the annotation called as primary key, which is provided by the Cassandra service that we are using over here. So let's now define the other attribute that we need for this service. So the next one will be the user ID of the user who have submitted the data. So let's also make it a unique identifier. Now comes the name of the user. So let's make that as a string. After that, we will store the image URL for a profile as a form of a string. Now comes the attribute that are related to this post. So the first attribute that we will be storing is the description for the post. After that, the image URL for the post, and the last the total number of like we are receiving for a particular post. So these are the minimum number of attributes that we need for creating a post into our Facebook application. And the last and the final attribute that we need over here is the timestamp at which the post got created over here. So this is actually important so that we can retrieve the corresponding date and time for a particular post. So let's also include the timestamp for a particular post. So let's start with this definition, and let's start with creating the constructor, and let's create the getter and setter for all this attribute over here. So let's start with creating the constructor for this post service. So over here I will right click and I will go to the source, then create constructor using field. So over here I will select all the attributes that we have defined over here. Let's click on generate. So here you can see we got a constructor over here. Let's also create a default constructor for this class. So I will again create on source, and over here I will be selecting the constructor with superclass. So over here I have also created a default constructor for this post service. Now let's create the getter and setter for all the attributes that we have defined over here. So over here, since I want to generate setter and getter for all the attributes, I will be clicking on select all and I will click on generate. So over here you can see we have created all the getter and setter that we need for this class. So I will save it and I will move to the next class of our service, and that is the controller. So let's start with creating the controller class for this post service. So over here let's create an empty package for the controller, and over here let's create the first controller class for the post service. So I will name it as post controller, and the first and the primary thing that I will be defining over here is I will be annotating it with the REST controller annotation. Now over here we have to set the request path for this controller. So as per our documentation that we have created, the request mapping path for this post URL will be /API/post service, which means that whatever the API that gets called using the URL, that is API/post service, it will hit the controller that we are defining over here. And within this controller, we have to set all the endpoints that we need for our backend service. So the first endpoint that we will be creating over here is the post service. So let's create a post service over here for submitting and saving all the posts from the front end into our backend, that is the Cassandra database. So let's create the post service over here. So for that, first I will create a post mapping, which will be the URL for the post. So over here the post URL will be save, which means that whatever the service requests that are coming with the URL, that is API's post service /save, it will go into the functionality that we will be defining over here. So let's create the functionality over here. So I will create a function called as submit post, and the return type of this function will be the array of posts that are getting saved into the database. And as a parameter to this post service, we will be sending all the metadata of a particular post within the body of the request. So over here we will be submitting the data using the request body. So if you are new to the Spring Boot microservice technology, you must be wondering that why I am submitting the data using the request body over here. So do not worry, while we will be integrating this code with the front end, it will be much more easy for you to understand the complete flow. So as of now, let's proceed further, and I will try to explain you as much as possible when we will be validating this API using the Postman service that we have installed in our first video. So let's proceed further and let's move on with submitting the data into our database. So over here we have got the post data in the variable called as body. Let's provide an empty return type over here so that our function doesn't give a compile time error. So I will return an empty array list from here. And let's define the next URL for our service, and that is the get URL. So over here let's define the get mapping URL. And let's define the function that will be responsible for getting all the posts into our backend. So in actual application, what you have to do is you also have to pass the user ID of the user for which you are retrieving the post. Because on real application, a particular user doesn't see all the posts that are available on Facebook. Rather, he can only see those posts which are being uploaded by his friends or community. So obviously we need the reference of the user ID for a particular post. But over here, since we are making a small application where we are not implementing all those services like friend request and all these things, and that is why I'm keeping the logic simple so that it will be easy for you to understand. But hopefully you guys have understood that why I'm telling that you need to pass the user ID of the user for which you are requesting all the posts for his dashboard. So over here we are done with the two endpoints for our post service. One is the post mapping, which will save all the data into a database, and another is the get service that will return all the data that are available on the database. Let's now create one more service, and that is the delete service for our API. So let's create a delete mapping, and let's create the function over here. So here you can see I have defined a function for deleting a post from our database, and the data that I am passing as the path variable is the post ID which I want to delete. So for example, I have a post with a unique identifier as 005, and if I want to delete that particular post from the database, I need to pass that unique identifier, that is 005, as our parameter, and once I receive that value in our path variable, I will call the service class for this delete method, and I will delete the corresponding post from our database. So over here, since we are done with our post controller, let's create the service class that will be responsible for actually building the business logic for our post class. So over here, let's create another package called as service class. And within this service package, let's create an empty service class over here. So I will name this class as post service. And the first thing that we have to do over here, I have to annotate this class with the annotation called as service, so that our Spring Boot application understands that this is the service class for our REST API. And over here, I will be creating three functions which will actually be responsible for doing the three operations that we have defined in the controller service. Number one is saving the data to our database. Number two, for retrieving all the data from our database, and number three, for deleting the post from our database. So let's define the three functions over here, and let's proceed further. So from our controller, that is the REST controller over here, let's call the service class method which will actually be responsible for doing all the action. And to call the service class method, what I will be doing over here, I will be creating a reference to the post service class. So over here I will be creating a reference for the post service class. And over here I will be annotating it with the annotation called as AutoWord. So from our first method, that is the submit post, from here I will be calling the first method that we have defined in our service class, and that is submit post to DB. And over here I will be passing the body as our parameter. So whatever the logic of submitting the data to the database will be taken care by the method called as submit post to DB, which we have defined within the service class. And over here we will be writing all the business logic for this method. So over here let's capture the return type of this method. So here you can see that the return type of this method is array list. So here also I will be retrieving all the data in the form of the array list. So let's define an empty array list over here, and let's name it as result. And over here in the return type, instead of returning an empty response, I will be returning the result that I am receiving from our post service. So let's save it. So that's great, we have not got any compilation error. Similarly over here we need to call the other service that we have defined in our post service. for retrieving all the posts and for deleting all the posts. So similarly over here, we also have to call the post service that we have created over here for retrieving the data from the database and for deleting the post from the database. So let's also call those functions from here called as retrieve post from database. And let's return the data that we are receiving from here. Similarly over here for the delete method, we also will be doing the same thing. So here you can see we have successfully incorporated the service class into our controller. So we are completely done with whatever the logic we need to write into our controller class. Let's move forward with the implementation of the service class. So over here, the thing that we need to do is we need to submit this data into the database, and we have to write the business logic for that. And to submit this data into the database, that is within the Apache Cassandra service, we have to build one more module, and that is the repository service over here. So let's create a repository service for our backend API. So let's create an empty package called as repository. And for the post service, I will be creating a repository called as the post repo. So this will be of type interface. And over here, the first thing that we have to do, we have to mark this as a repository class so that our Spring Boot application understands that this comes under the repository section of our application. And over here, since we will be connecting this repository class with our NoSQL server, that is the Cassandra database, we need to extend the class from the Cassandra library. And for that, over here, we will be extending the Cassandra repository from here. And within this Cassandra repository, we have to pass two parameters. One is the entity type that we are saving over here, and that is the post entity. And here in place of the ID, we have to pass the data type of the unique identifier for this post class. So you can see that within our post class, post ID is our unique identifier, and the data type of this post ID is the UID over here. So similarly over here, within the repo class, we have to specify it with the data type that is UID. So I think this flow is clear to you right now. Now over here, let's define the method that we need to override for retrieving and submitting data into our Cassandra database. So the first method that we will be overriding over here is called as findAll, which will be responsible for retrieving all the posts from our database. And the return type of this findAll method will be an array list of all the posts into the database. And the next method that we have to override over here is the save method from the Cassandra repository. So let's create the function called as save. And over here we will be submitting the post as our parameter for this method, and the return type of this method will be the post that we are submitting. So basically these are the two methods that we need right now. So let's start with implementing the service class, and let's leverage this method that we have override from the Cassandra repository. So let's go to the service class and let's implement the business logic for this method. So over here within the service class, the first method that we will be implementing is the submit method over here, which actually does the functionality of submitting a post into our database. So let's start with the implementation of the functionality for submitting the data to the database. So over here, to submit a data to the database, the first thing that we will be doing is we will be taking the advantage of the functionality that we have extended over here, and that is the save method that is coming from the Cassandra library. So to call this function over here, the first thing that we will be doing is we need an object or the reference for this post repo class. So for that over here, I will be creating a reference of this class. So let's create an object over here, and let's annotate it with the AutoWrap annotation. So over here we got the reference of the post repo. Now let's utilize the save functionality over here. And to call this function, what we have to do, from here we will be calling postrepo.save, and within the parameter we will be passing the post data which we will be receiving as the request body within our API call. So let's pass the data over here, and once the data gets saved into our database, the things that we have to return is a list of posts we have in the database. And for that, what we have to do, we have to call the function, and that is retrieve post from DB. And for that we will be calling the functionality retrieve post from database. So once this functionality is getting called, this is actually returning all the posts that are available on the database, including the new post that we have saved right now. So let's save the return type of this post. So that will be an array list of post. And let's return this result from here. So if you are having any doubt or you are not understanding the functionality what we are doing over here, just wait for a while. Once we are done with the entire functionality over here, I will explain each and every flow so that it will be much more clearer for you to understand the complete flow over here. So let's start with implementing the next functionality, and that is retrieve post from DB. So this is quite an easy functionality to retrieve data. And to retrieve the data, what we will be doing, we will be calling the post repo function, and that is find all. So if we call the functionality called as find all, this find all method will actually return us all the posts that are available on the database. And to capture all this, we will again hold this value in an array list called as result. And over here as a return, we will be returning the result from here. So the implementation of this will be more or less similar. Now let's start with the implementation of deleting a post from our database. And to do that, what we have to do, we have to again call the post repo functionality, that is delete by ID. And over here we will be passing the post ID as our parameter. So I think we have not defined the post by delete method over here. So let's define over here. And once this post get deleted from our service class, means from our DB, what we have to do, we have to return the rest of the undeleted post from our database. And for that, again we will call the retrieve post from DB functionality. So let's copy this and paste it over here. So here you can see we have successfully completed the entire flow of saving a post, getting the post, and deleting a post from our database. So let's see whether this functionality is actually working or not. And once it starts working, I will explain you each and every line of this code so that it will be much more easy to implement any other functionality that you want for your business. So before we successfully run this application, we first need to connect our Spring Boot application with our backend database, and that is Cassandra. So let's see how we will do it. So in our first video, I have already shown you that how to install the Cassandra into our machine. Let's run this Cassandra over here, and let's start with connecting this application with that DB. So the first thing we have to do over here, within this terminal, we first have to run our Cassandra service. And the command to run the Cassandra application is cassandra-if. So let's click on enter. So this setup will take a few minutes to run. So over here you can see our Cassandra service is up and running. So let's open one more terminal and let's see whether it is actually running or not. So let's go to the database shell. So the command is, so over here you can see our Cassandra service is up and running and we are within the Cassandra shell. So that's great. Now let's connect this backend service with this database, and to create a configuration with the backend application, what we have to do, we have to go to the application.properties within this resource folder. So over here we will go to the application.properties, and over here we have to write the configuration that we need for connecting to the database. So let's see how we will connect to our database. So connecting to a NoSQL database from Spring Boot application is also quite similar the way we connect the MySQL server. So over here, the command to connect to a Cassandra server, that is a NoSQL database, is something like this. So do not worry about this code. I will be providing this in the description below. So let's understand that what we are doing in this connection string. So over here you can see we are configuring over here the Cassandra database. And the first attribute that we are setting is a local database, that is data center 1. So since the Cassandra server is running in our local database, that is why we have to mention is as data center 1. So the next attribute is the key space name, which is actually the name of the database we want to create on the Cassandra server. So over here for this application, let's make the key space name or the database name as Facebook clone. Now since this application is running on the local server, That is why I am giving the port ID of this server as localhost, which is nothing but 127.0.0.1. And the port at which it is running is 9042. And over here, similar to our MySQL database, we are mentioning that create if not exists, which means that if the database is not there in our Cassandra server, then create the database if it does not exist. So this is the simple connection string for connecting our NoSQL Cassandra server to our Spring Boot application. So let's save it and let's see whether everything is working fine or not. And before running this command, what we have to do, we have to go to our terminal and we have to create a key space over here. And the command to create a key space on the Cassandra database is something like this. So over here you can see we are creating a key space called as Facebook clone. And since this is a NoSQL database, we have to provide some of the other attributes such as the replication factor. Because you know, all the NoSQL database are highly scalable and also it should be durable, which means if any of the database fail to serve the purpose for which it is meant for, or if any of the database gets crashed at some time, the other database which are exactly the clone or the replica of the master database will come into action. And that is why when we are initializing a key space or a database in the Cassandra service, we mention the replication factor of that database. Means how many instance or how many clone of the database should exist in our memory so that at any point our database does not crash. So this is the main reason why we are mentioning the replication factor with different type of replication strategy and the replication factor over here. So the most common strategy that is used for the replication factor is the simple strategy. So over here we have given the strategy as simple strategy and over here I have given the replication factor as 2. So let's execute this command and let's create the key space in our Cassandra service. So let's paste it over here and let's click on enter. So over here you can see this command got executed successfully. Let's see whether we have created a key space called as Facebook clone or not. And the command to see all the key space is describe key space. And over here you can see we have successfully created the key space over here. So that's great. Let's now run the application and let's see that everything is working fine or not. So we'll go to the main class and we will click on run. And great, you can see over here our application has been connected to our database and it is working fine in the port 8080. So right now, since we have connected our application to our database, let's now test the application that we have created over here. So for that, for using this application, what we will be doing, we will be using an external tool and that is the PostMan service. So let's open PostMan and let's see whether our API that we have created is working fine or not. So let's start with checking all the services that we have created for our post service, and the URL or the endpoints for this post service are as follows. So let's test it one by one. So the first service that we will be testing is the get method over here. So we'll type localhost 8080 since our application is running on the 8080 port, and after that we have to mention the URL that we have defined in our controller service. And over here you can see we have mentioned the URL as /API/post service for creating our post controller service, and the URL for creating all the posts from our database is /getPost. So let's hit this endpoint and let's see whether we are getting all the posts from our database or not. So we'll again go to the Postman service and over here we will write API/post service /getPost. And if everything works fine over here, we should get an empty response over here. Since right now our database for the post is completely empty and it should return an empty response over here. So let's click on send and let's check this URL. And bingo, you can see we got an empty response from our server. Means there is no post that is available into our database. So right now our application is working fine until now. So let's now test the next endpoint for our API service, and that is the save over here. And you know the method that we use for saving a post or saving anything into the database is the post mapping. So for that, what I will be doing, I will be changing the method to post, and also I will be changing the endpoint URL over here, and the URL which is responsible for saving the post is called as save. So you can see this is the URL which belongs to invoke this method. So over here, if you look carefully, you can see within this submit post, we are sending the request body as our parameter into this service. So similarly over here, we have to create a request body over here. So over here in the Postman, we will go to the body section and we have to create a request body over here. So the first entry that we will be sending as our request body is the user ID who have submitted the data. So let's now create the payload or the request body for this post API. So over here you can see the post ID is the primary key, and basically this will be an auto-generated number which will get generated while a post gets submitted into the database. And the logic to generate a post ID we will be doing into our service class, and that is the post service. So since this is an auto-generated one, we will not send this value from our payload. The next thing that we will be sending from our payload is the user ID over here. So the user ID will be actually a form of a UID. So let's create the payload with one of the attribute as user ID. And the payload that we will be passing over here will be a form of a UID. So let's put a dummy UID over here. So you do not have to worry. I will be also giving you the payload for testing this application, and you will find this payload in the description below. So let's concentrate over here and let's see how the things are going over here and how we will be executing and testing this functionality. So the next attribute that we will be passing is a username. So let's create a dummy username over here. Let's give the username as Anindo. Next comes the user image, which we will be providing as a dummy URL as of now. Number 4 is the description of our post. And the last one is the post image URL, which is actually the URL that we will receive after we upload an image into our Firebase system. So let's over here also give a dummy URL, and that's it. So this is the total attribute in our payload that we need to submit while submitting a post request over here. So if you actually follow the payload and the attribute that we have defined in the post, you can easily see that I have skipped few of the attribute from here. Number 1 is the post ID, number 2 is the like, and number 3 is the date and the timestamp. Because of the reason, all these 3 attributes we will be computing on the backend service, and we will not be sending it into our payload from our frontend. So let's create this logic into our backend service. So over here within our post service, what we will be doing, while the post data gets submitted to our post method, over here we have to initialize few of the values that are coming into the post data. And the first attribute that we have to initialize over here is we have to set the unique identifier, that is the post ID over here. So let's generate a unique identifier for each and every post. So what we will do, we will select the UID.random. So this will basically generate a random unique identifier for each and every post that we are creating over here. So there are plenty more ways by which you can create a unique identifier for your application. So you can also use some other external libraries which creates the UID based on the timestamp. Now let's initialize the next attribute that we need to define over here, and that is the total number of likes. So since at the very initial stage when our post is getting submitted, obviously the number of likes should be 0. So we will define the set likes as 0. And then we need to say timestamp for this post, and we will be passing the date time over here. And to get the proper system date and timestamp, what we will be doing, so over here using the datetime functionality of the Java framework, we have created the timestamp for a particular post. So let's understand what we are doing over here. So over here within this request body, we are sending the user ID of the post who is actually posting this data. Number 2, the username of the user. Number 3, the image, description and the post image over here for a particular post. And over here on the back end, we are generating the date and timestamp for a particular post, number of likes and the unique identifier for this post. And thus over here we are creating an entire payload over here which we will be submitting into our database. So let's save it and let's rerun this application and let's see whether each and everything is working fine or not. So here you can see our application is running successfully at the port 8080. So let's now submit this post that we have created over here. So what we'll do over here, I will click on send. And if both the payload and the service that we have created for this post URL is correct, we should get the entire post into our return type. So let's click on submit and let's see what we are getting in our return type. So let's click on send. So over here you can see we are getting an error from our backend, which means that either the payload or the service that we have created is not correct. So let's debug it over here. So we'll go to our console and let's see what is the issue. So over here you can see it's showing that the invalid null value for the column called as post ID. Means we are not sending a correct value for the post. So let's see why. Because we know that we are not sending the post ID in our payload. So there must be some wrong implementation that we have created over here. So over here you can see that by mistake, instead of creating set post ID, I have created set user ID, and that is why I'm getting an error over here that the post ID is null over here, which is correct. So let's change it to set post ID. So let's click on save and let's rerun it one more time and let's see whether we get any further error or not. So while creating this huge type of application, it's definitely quite expected that you will face some of the error while building the application. And the more and more you debug and try to solve this problem during the runtime, it will be much helpful for you to learn more and more over here. So let's resolve this issue one by one and let's build this application. So again the application is running successfully. Let's again post this same URL with this post data what we have created over here. So let's click on send. And bingo, this time you can see we got the actual post that we have submitted. So here you can see that this is the user ID that we have passed from our front end, which is nothing but this one. This is the post ID which got created in our backend as our unique identifier. This is the user ID and the name of the image that we are sending over here, and also the total number of likes for this post is 0, and this is the timestamp which we are generating also in the backend. So bingo, this is working as we have expected. Let's now create one more payload and let's see whether we are retrieving both the posts into our response or not. So let's create one more payload over here. Let's change the username as technical interview and let's provide a URL over here. So let's click on send and this time we should see 2 posts from our database. So let's click on send and great, you can see over here we got 2 posts from our DB. The one over here is the current one which we have just submitted right now, and this was our previous one. So bingo, our 2 of the endpoints that we have created for our post service is working brilliantly. Let's now test the last and the final service that we have created, and that is the delete method over here. And over here for deleting a post, we should pass the post ID in our parameter. So what we will do, we will change the method of this request to delete, and also we will change the URL over here. And over here within the path variable, we will be passing the post ID which we want to delete. So over here, let's delete this post from our database. So let's copy this one and let's pass it in our path variable. So if everything works fine after we trigger this endpoint, this post should get deleted from our database and we should get only this, the last one, as our response type. So let's click on send. So over here you can see we have again encountered a problem, and I know the problem that we have created in our service class. Because over here I want to show you the functionality by which we are sending the value in the path variable. Because in our previous tutorial, while we were implementing the Instagram application, over there I have not taken a use case for the path variable, and that is why in this tutorial I have intentionally created a path variable functionality so that it will be easy for you to understand and implement any REST API service for your use. So over here you can see I am expecting a path variable, that is post ID over here. So what additional thing we have to do? So over here we also have to define the same path variable that we have defined over here, so that from the URL the application can understand that this is the post ID that we are sending from our front end, and it can map this post ID with the path variable over here. So I think this is clear to you. So let's save it and let's rebuild this application, and this time it should work exactly the way it should run. And let's go to our Postman. So just like before, we will select as delete, and this time we will be deleting this one. That is the first post from here. And let's click on send. And bingo, you can see this time it is working as we have expected. So I hope this makes clear to you that how a REST API works internally, and how we can create any endpoints for your REST API, and we can create any functionality over there. So let's right now define each and every component that we have learned over here, so that we can move forward with our rest of the service that we need to create for building our application. So as we have defined in our documentation, for the creation of the post service, we need to create three endpoints. Number one is the post for saving the data, the get for retrieving the data, and delete for deleting a particular post from our database. And as you know, the main component from a Spring Boot application is a controller, which controls the endpoints. Number two, the service, which actually contains the business logic of deleting and saving a value into the database, and the repository, which actually connects the database with the application. Now let's go through the code and let's see how we had implemented over here. So the first thing is like we have first defined a post component over here. So this is actually the entity class or the bean class for our Spring Boot application. Now comes the first class of our Spring Boot application, and that is the post controller. So over here in the post controller, we have defined a base URL, that is the API/post service, for targeting all the services based on the post mapping. And within this post controller, we have created three methods, one for handling all the save method, one for handling all the get method, and one for handling all the delete method. And based on this endpoint, we are diverting our control flow to the specific service class that we have defined over here. And within this service class, we are creating the exact logic that we need for saving our data into the database and for retrieving and deleting our data from our database. So this is the general flow by which our REST API works using the Spring Boot application. So hopefully until now you have thoroughly understand each and every component of our Spring Boot application, and you are already familiar with the way by which we create a Spring Boot REST API service. Now let's move forward to the next component of our Spring Boot application, and that is the user service. And for this user service, again we will create one more microservice which will have these four components. Number one, the post for submitting the user detail, the get for retrieving all the user that we have on our Facebook application, another get method for retrieving the detail for a particular user. Since over here you can see I'm sending the user ID of a particular user to retrieve the metadata of a particular user, and then comes the delete for deleting a user from the database. But over here, while implementing the user service for our REST API, this time I won't be coding the delete functionality over here. This you can take as an enhancement function, since I have already shown you how to create a delete endpoint in our post service. So I hope you guys can easily implement this delete functionality for your API creation. So let's move forward and let's create the user service for our backend. So let's create the next service for our application, and that is the user service. So let's start with creating the bean class or the entity class for our user service. So over here within this entity package, I will be creating one more class called as user class. And since this is one of the table for our database, let's annotate it with the table annotation, and let's rename it as user. Now let's see what are the attributes that we need to define over here for creating our user API. And as per our documentation, the attribute that we need for the user entity are the user ID, username, the image URL, the activity status, and the joining date. So let's include all these attributes one by one. So the first one is the user ID. which will be the primary key for our user table. So let's annotate it with the annotation called as primary key. Now let's define the other attribute that we need over here. So the next one will be the username over here, which will be of type string, followed by the user image, which will be the URL for the image for a particular post. So this will be also of type string. Now comes the last two, and that is the activity status and the joining date. So activity status is nothing but whether a person or a user is active or not. So this will be basically a flag which is of type boolean, which will denote that whether a user is active or not. And the last but not the least is the timestamp of joining our Facebook account. So over here we are done with all the metadata that we need to save for a particular user. Let's now create a default constructor and parameterized constructor for this class. And let's also create the necessary getter and setter for this user entity class. So over here we will select all the attributes and let's click on generate. So here we are done with our first class for our service, and that is the user class. So now let's move on to the next component of our user service, and that is creating the controller for this class. And to create a controller, what I will be doing, I will be creating a controller class for this user service. So over here let's create a controller and let's annotate this function with the annotation called as controller. And let's also set the request URL for this class. So over here you can see, as per our documentation, the common request URL for this class will be API/user service. So let's also implement that. So over here we will give API/user service. So since now over here we have defined the general controller for this user service class, let's now define the separate controller for the post and the get. And as we have discussed, I will keep the delete unimplemented so that you can take up as an enhancement problem. So let's implement the two methods for this user service. One is the post and another is the get. So over here let's first implement the post method. So for that we will define a post mapping over here and the endpoint will be save. So over here I have defined a method called as save user metadata, and within this I will be passing the user data, that is our metadata, as our request body. So hopefully right now all these are making some sense to you, that why I am annotating this as request body, and over here why I am marking this method with the post mapping. So now let's put an empty return type from here and let's move to our next functionality, and that is the toGet method over here. So if you look, the difference between these two get methods for this user service class is, for the first get method, this will return all the users that are available on our Facebook application, and we will use this functionality for creating our messenger service, where we need to show all the active users for our messenger service. And over here the second get method will retrieve us metadata of a particular user. For example, for a particular user I want to fetch the username and the image name for that particular user ID, and that is when we will be using this REST API for our functionality. So let's implement both of them together over here. So over here you can see I have created a get mapping method with the request mapping as get user details, and over here I will be implementing a function that will return all the users that are available on the Facebook application, and that is why I am returning an array list of users. I think this is making sense to you. Now let's move to the next functionality of the get mapping, and that is getting the user data or the metadata of a particular user. And for that what I will be doing, I will be setting one more get API over here, and let's call that as get all users. And from the list of all users I want to get the metadata of a particular user, and that is why I will be passing the user ID within our path variable. So let's define the functionality over here. So over here, if you just carefully notice, I'm trying to fetch the metadata of a particular user for which I'm sending the user ID over here. So since right now we are done with our controller class for our user service, let's create the service class which will hold all the business logic for each and every method that we have defined in our controller class. So for that, we will be creating a class called as service class. And let's annotate it with the annotation called as service. So the first thing that we have to do is we have to define three methods for handling all the URLs that we have defined in our controller class. Number one is for saving the user detail. Number two, for retrieving all the user detail for our messenger service. And number three, getting the user detail of a particular user. So here within the service class, I have created three methods. One for handling the save functionality, second for retrieving all the user metadata for our messenger service, and number three for getting the metadata for a particular user. So let's now go to our controller class and let's call the service class from our controller. So for that, I first need to create a user service reference and let's annotate it with AutoWare annotation. And from here I will be calling each and every functionality that we have created in our service class. So to submit a data to our database, the functionality that we have created into our service class is called as submit metadata for user. And over here we will be passing the user metadata as our parameter. Now the next is retrieve all, for which the service class method that we have defined is called as retrieve all user detail, which will retrieve all the user details available in our database. Now the last but not the least is get user detail, which will retrieve only user metadata of a particular user ID. And for that, the API service that we have created is get user metadata. So I think this is clear to you until this point. Now let's move to the user class and let's implement the business logic for this. And to save the data into our database, what we need to do, first we need to create a repo class for connecting to our Cassandra database. So over here I will first create an interface for the user repo and let's extend the Cassandra repository over here. And as I have told you while creating the post controller, over here in the parameter we have to pass two parameters. One is the entity for which we are creating the user repository, which is of type user, and next is the data type of our primary key for the user service. And over here you can see the data type for our primary key is UID. So here also within our repository we will be passing the value as UID. Now let's over here override the functionality that we will be using from our service class. So here you can see we need actually three methods. One for submitting the user detail, one for retrieving all the user detail, and one for retrieving the specific user data. So let's over here define three functionality that we will be overriding. So here you can see we have overridden three functions from our Cassandra repository. The first is the save for saving the data into our database. Second is find all for finding all the user entry from the database. And next is the find all by user ID, which will help us in retrieving the user metadata of a particular user by its user ID. So let's save it and let's move to the service class for our user service. And let's implement the business logic over here. So as we have already discussed, while creating the payload for our user metadata, we will be actually passing two attributes. One is the username, which is set by the user while creating their profile, and number two is the user image, that is the profile picture of the user. And the rest, all of the attribute, that is the user ID and the activity status and the joining date, we will be defining in the backend, because this will be an auto-generated number from our backend, and this is dependent on the activity status, that whether the user is logged in or not, and this is basically the date and timestamp for the particular user on which he or she have opened the account. So over here in our backend support, we need to provide the logic for generation of this user ID, the user status and the joining date. So for that, what we will be doing, before saving the data into our database, we need to set the user ID for a particular user, which will be actually a unique identifier number for a particular user. So we will again use the UID random function over here for generating the user ID of a user. Now comes the next, and that is the activity status. So it's quite obvious that when someone is creating or login to our application for the first time, the activity status of that user will be active. So we will set this activity as true. And next comes the third, and that is set joining date timestamp. And for that we will be fetching the date and timestamp at which the user got created. So let's copy the same logic of getting the date and timestamp. So over here we have set all the necessary payload that we need for saving our user data into our database. Now let's actually save this data into our database, and for that we will be using the user repository .save, and over here we will be passing the payload that we have just created right now. So I think this is clear to you. And as more and more REST API you will be creating, you will get familiar with the approach, because the approach of creating any of the REST API is more or less similar. So let's proceed with our next implementation, and that is retrieving all the user detail. And to retrieve all the user detail, what we need to do is we just need to call the user repo.findAll, which will actually give us all the users that are available into our database. Next comes the user by ID, and to get the user detail for a particular user, we will be calling the functionality that we have defined in our repo function, and that is find user detail by ID. And that's it. Over here we are done with creation of the user service for our Facebook API. So let's now again test this application and let's see whether everything is working fine or not. And if everything is working fine, then I will again explain you the entire end-to-end flow so that it will be easy for you to understand. So over here we will again go to the Postman, and the first service that we will be testing is the Get API, and change the request mapping over here. And let's click on send, and if everything works fine, again over here we should get an empty array as our response, because right now we do not have any user metadata saved in our DB. So let's click on send, and over here you can see we got an empty response from our backend, since there is no user details saved in our database. So let's now try the next URL or the service point that we have created, and that is the post service for the user data. So we'll select over here as post, and we will change the URL to save. So as you know, while saving the data into our database, we need to send the user detail in the request body along with the request. So we have to create the request body in the Postman application. So the request body will be in the form of the entity class over here, where we have to send the username and the user image as the two request parameters. Because you know that we have already created the user ID, activity status and the joining date in our backend. So let's create the two attributes in our payload, and that is the username and the user image. So over here we will create a payload. First will be the username. Let's give it as Anindo, and the next is the user image. So over here we will be giving a dummy URL. So let's give a dummy URL over here, and let's click on send. And if everything works fine over here, in the JSON response we will get few things. Number one is the user ID of this user, the username and the user image that we are sending as a parameter, the activity status and the joining date of the user. So let's click on send, and let's see what we are getting as our response. And great, over here you can see that as our response to our request, we are actually getting the user ID, username, the name of the image, the activities and the joining date over here. So we can conclude that the post service is also working for our user service API. So let's create one more user in our database. So this time let's give the username as technical interview. So let's click on send. So over here also we should get another response for our backend with the corresponding detail of the user. So let's click on send, and great, you can see another user ID got created with this configuration. So let's now check the rest of the endpoint that we have created for our API service, and that is the get user detail. which we will be using for our messenger service. So what it actually does, it will retrieve the user detail of all the user available on our Facebook database. So let's hit that endpoint, and for that we will be selecting that as get, and we will be changing the URL over here. So let's click on send, and great, you can see over here we are getting both the user detail in our response. So this is the actual data that we need for creating our messenger service. So for example, there are 50 users that are using our Facebook application, and while creating our messenger service we will actually hit this URL to retrieve all the users that are available on the Facebook application, and based on their activity status we will show that person as online or offline. So hopefully that makes sense to you that why we have created this endpoint for our service. So since now over here we have checked two of our endpoint, let's check the last one, and that is the get user detail. So over here we will again change the URL, and over here in the parameter, that is in the path variable, we need to pass the user ID of the user for which we want to retrieve data. So for example, I want to retrieve data for this user ID, and if I hit this endpoint, only the detail of this user should come up in the response. So let's check that out. So let's click on send. So over here you can see we got a 500 error from our backend. So let's see what mistake we have done in our backend. So let's go to our code and let's debug the console error. So over here you can see I'm getting an index out of bound exception. So let's see why. So the problem is over here you can see, though I am trying to retrieve the user detail of a particular user, but over here I am not sending the user ID for which I want to retrieve the particular user detail. So over here by mistake I forgot to put the user ID over here. So let's put the user ID over here, and also we need to modify the repo class over here. So let's save both of them and let's rerun this server. So I hope this is clear to you that why we were getting the error, because we were trying to retrieve the detail of a particular user, but over here in the repo class we were actually not sending the user detail which we should have sent. So hopefully that was the reason why we were getting the error in our console. So let's again go back to our Postman service and let's check this API. So over here we will keep everything same and let's click on send, and if everything works fine we should get the user detail of this user that we are sending as our path variable. So let's click on send, and great, you can see we are getting the response of a particular user as our return type from all the user detail we have in our DB. So that's great. Now all the APIs that we have created for our user service class are actually working fine. So I hope you guys have thoroughly understand the code what we have done for our user service class. So let's have a quick recap. So over here first we have created an entity class for the user detail, where we are creating the user ID as our primary key, and we are passing the username and the user image as our parameter, and based on the login details we are getting the activity status and the joining date of the user. And for creating a user service class, we have first created a controller class over here, and the endpoint of this user API is API/user service. And over here we have created three services, one for post and two for get, for retrieving the user detail from our database. And the actual logic of implementing the save and the retrieval of the data we are doing in our service class, and for which we have created the user service class, where we are creating our payload for our post API for saving the data into our database, and these two for retrieving the data from our database. And the repo service that we are creating for connecting our code to our Cassandra service is the repo class over here. So I hope this makes completely sense to you that how we are creating our repo service for our Facebook API. So let's move to our next service, and that is the status entity. And over here, for persisting the user status detail into our database, we are creating our next service, and that is the status REST API. And over here for the status entity class, we are actually storing four attributes. One is the status ID, which is again an auto-generated identifier. Number two is the user ID, which will denote that which user have actually saved the corresponding status. The status image, that is the URL of the image which the user have uploaded in the form of the status, and the date and timestamp for the particular status. So these are the following data that we will be saving for our status entity. and the endpoints that we will be creating for this status entity are the post and the get. So the post one will be for saving the status entity into our database, and the get API will be used for retrieving all the status that are available on our Facebook application. So here also we will not be implementing the delete functionality over here. So if you want, you can take it as an additional activity as an enhancement problem. So let's start with building our status service for creating our backend support. So over here, since you guys are already familiar with how to create the REST API for each and every service, so this time I won't be explaining much of how to implement the REST API over here. Rather, I will be implementing the entire code in the single iteration without explaining much about the detail of the code, because I actually want you guys to implement the rest of the two services that we want for our Facebook application, and that is this status service and number two, the comment service that we need for creating our Facebook application. So let's start with building our status service over here. So hopefully you guys can follow me while I will be coding, and if you have any doubt, feel free to ask me in the comment section below. I will be happy to help you further with any details that you need for building your application. So let's start with building the third API for our Facebook application, and that is the status service. So over here you can see we are done with our status class. Let's move to our controller class for our status service. So over here you can see I have created two endpoints, one for saving the status into our database and the next for retrieving all the status from our database. So similarly, let's create the service class which will be responsible for handling the business logic. So let's create the status service for our application. So over here you can see we have created the business logic for our status service. So here we have updated all the metadata that we need for creating the payload, and over here I have invoked the finder method from our repo service that we have created for our status repo. And over here as a return type I am sending the status and the complete list of status as our return type. So let's invoke this service class functionality from our controller class. Thus over here you can see we have created all our classes required for our backend support. So over here we have created our status controller class, the entity class, repo class and the service class over here. So let's now test this status class over here and let's see whether everything is working fine or not. So let's run this application and let's go back to our Postman service. So the first service that we will be checking is the get URL over here. So over here we will select as guest and we will change the request URL over here. And let's check the first function, and that is get all status. So right now, since in our DB there are no status available for our status service, so we are expecting a blank value over here. So let's click on send. And over here you can see, as expected, we are getting an empty response from our backend. So let's save one of the status and let's see what is the request body we have to create over here for invoking our save functionality. So we'll go to a status entity class, and over here the attribute that we have to give as a payload are the user ID and the image URL. So let's create the payload like that. So let's click on send, and if everything works fine, we will get the enter status object as our response. So let's click on send. And great, you can see over here we have saved the data successfully into the DB, and we have got a status ID and the upload time of the status. So right now everything is working as expected. So let's create one more post over here, and let's retrieve both of the status in the single request. So we'll select the get URL over here, and let's change the URL to get all status. And great, you can see we are retrieving all the status that are saved in our DB. So I hope you guys have thoroughly understand the way how we are incrementally creating our APIs over here. And this is the way by which you have to create each and every functionality on your backend so that you can support the UI framework that you have created for your frontend. So let's create the last and the final component of our REST API service, and that is the comment section. So over here I will totally skip that part of the video and I will keep that as your enhancement problem. So I hope that after seeing that how I am creating each and every API service over here, you can also create the last and the final API service for your comment section. So let me skip the next part of our API implementation, and that is the comment service. So for creating the comment service also, you primarily need two endpoints. Number one, save, and number two, get, for retrieving all the comment attached to a particular status. So hopefully you guys can implement the comment service for our Facebook API. So if you're stuck in between while implementing the service, feel free to go through my code that I will be providing you in the comment section. But I will highly recommend you try to avoid as much as you can to go through my code so that you can independently learn how to create the REST API that you need for your business. And after that we will go into our Cassandra database and we will see in detail that what are the data that got persisted in our DB. So until now we were only seeing the data and we are only saving the data from our Postman service. But after this we will go in detail within our database, that is within the Cassandra service, and over there in detail we will open up each and every database and table and we will see how the data are getting stored over there. So I will request you to pause the video over here so that you can independently create the comment service for your API. So let's move to our next part. Hopefully you guys were successful in building the REST API for our comment section. So let's go through my code and let's show you what I have developed over here. So let's start with the entity class over here. So for the entity class over here, I have included this 5 attribute over here. One is the comment ID, which is the primary key for our entity class. Next are the post ID and the user ID, which means that for which post the user is providing a comment. And over here we have the actual comment and the timestamp at which the comment was submitted. And after that we have created a controller for the comment, which is more or less the same. And also we have created a service class for this comment section. The only thing that I want to show you over here is the get all comment for this API. So over here, if you just concentrate on one thing, over here to get the comment for a particular post, over here we are passing the post ID as our parameter. And over here we are trying to search our DB by the function called as find all by post ID. Because over here in this scenario, we are not trying to find out the entries in our DB by our comment ID, rather we are trying to find out the comments based on the post ID, because each and every comment is attached to a primary post. So there can be thousands of comments for a particular post, and that is why we are passing the post ID over here. And in our repo class that is over here, we are trying to search it by find all by post ID. And over here you can see I have given a special annotation over here, and that is allow filtering. And the main reason why I am using this allow filter over here is because of the reason we are querying a NoSQL database. And since over here we are not searching based on the primary key, and that is why I am indexing this attribute with the allow filter over here. So if you are facing any issue while building this comment API, feel free to go through my code so that it will be easy for you to understand. So over here, I have already tested my comment API using the Postman service, and it is working as expected. So over here, we are completely done with all the 4 microservices that we need for building our Facebook application. That is, one for submitting the post, one for submitting the status, one for creating a user account for our Facebook application, and one for submitting the comment for a particular post. So there are plenty more services that you can create for your Facebook application. For example, you can create another service for the like and the react post, so that whenever a particular user like a particular post, you can capture the user ID and the post ID into your database, and you can increase the like count over there. So over here, though I am not implementing all those components over here, but maybe in the final component that I will be uploading into Git, you can find out all the REST API that you need for creating an end-to-end clone of your Facebook application. So do remember to check out the code that I am uploading on my GitHub account. So since now over here we are done with all the REST API service, so as promised, let's now go into our Cassandra service and let's see how the data are getting saved in our NoSQL server. So for that, we will go to our terminal and we will log into our Cassandra service. So over here, to go into the Cassandra shell, you have to type cqlsh. So over here right now you can see I am within the Cassandra shell. So let's first go into our key space that we have created. So let's first check out that what are the key space available in my machine. And the command for that is describe key space. So here you can see we have about 8 key space over here. But the key space that we have created for this application is Facebook clone. So let's go within this Facebook clone, and to get inside a key space we have to use followed by the name of the key space. So right now we are within the key space, and that is the database for our application. Let's now see what are the tables that got created when we were implementing our backend services. And to see all the tables that are present over here, we have to write describe followed by the key space name. So over here you can see this is giving a huge structure of the tables that they have created on the runtime. You can see that under the hood, our Spring Boot application have created a lot of tables with lot of attributes over here. So if you want to know in details that what all these things means over here, you have to go to the documentation provided by the Cassandra application. So this is right now out of scope for this video tutorial. So over here you can see that while we were creating a repo with the name as status, under the hood it have created a table called as status, where we have few of the attributes such as the UID, status image, the upload time and the user ID. And over here there are few more attributes and parameters that they are defining for building a NoSQL database. Similarly over here we have one more table called as comment, another for user and another for the Facebook post. So altogether there are 4 tables that got created. And to see only the name of the table without the DDL structure, and the command is describe table. So it's describe, not describes. So over here you can see this is listing out only the name of the 4 tables that it got created while we were running the application. One is the status, one is the comment, another is the user and another Facebook post. So let's go into one of the table and let's see how they are storing the data over here. So let's go within the Facebook post over here. And to see the data within a particular table, we have to write select star from the table name. So let's go inside the table called as Facebook post. Sorry, I got a typo over here. So over here you can see this is our Facebook post table, and you can see all the data over here got persistent within our database. So let's go into our comment table and let's see what are the data available over there. So over here you can see for the comment section we have 5 entries over here. And you can see that for a particular post, that is this one, we got 4 comments over here, which are having a unique ID over here. So while we will be integrating this code with our front-end application, at that time for this post, we can see the 4 comments that we have saved over here. So I think this makes clear that how we are saving all our data in our Cassandra service. So this brings us to the end of our this series on the API creation, where we have successfully created all the REST API that we need for creating the backend support for our Facebook application. So in our next video tutorial, we will be integrating the front end that we have created in our earlier video with the backend service that we have created in this video, and on a whole we will be creating the entire full stack application and we will be hosting it into our cloud service. So in our next video tutorial over there, we will see how we will integrate the front end with our backend application, and also we will see how we will upload the image into the Firebase application. So let's see you on the next video tutorial, because there will be plenty of new things for you to learn on our next video, where we will be integrating all the things together, because that is the main part of being a full stack developer, that is integrating the front end code with our backend service. So see you on the next video, and if you have liked this video, don't forget to like and share this video. And if you are new to my channel, don't forget to subscribe and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So see you guys on the next video. Thank you.